Let's explore the rate limiter workflow step by step in a more interactive and humanized way. Step 1. A new request arrives. Imagine you're the client. You've sent a request to the server, maybe to fetch your favorite music playlist. Before anything happens, your request meets the rate limiter, which acts like a gatekeeper. What happens? The rate limiter receives your request and starts checking who you are and what you're asking for. It extracts details like your user ID, the API endpoint you're accessing, and the time you sent the request. If it hasn't seen you before, it creates a record to keep track of you. Why? The gatekeeper needs to know who's knocking at the door and whether they've been knocking too much lately. Step 2. Checking the rules. Now the rate limiter looks at its rulebook. 1. What are the rules? You can only make a certain number of requests in a given time. For example, no more than 100 requests per minute per user. The system can only handle 1,000 requests per second globally. 2. What happens? The rate limiter checks how many requests you've made so far and compares that to the rules. It uses clever algorithms like token bucket or sliding window to figure out whether you're within the limits. 3. Why? To ensure fairness. If everyone sends too many requests, the system could crash, leaving no one happy. Step 3. Making a decision. Now it's decision time. The rate limiter has 3 options. 1. Allow the request. If you're within the limits, your request goes through to the application. You get a response like, "Here's your playlist." 2. Reject the request. If you've gone over the limit, the gatekeeper says, "Hold on, you've sent too many requests. Try again later." You receive an HTTP 429 response, which means too many requests. Sometimes you might even get a retry after hint. 3. Queue the request, optional. In some cases, instead of rejecting your request outright, it might be put in a queue. That way, it can be processed later when things calm down. Step 4. Updating records. After the decision, the rate limiter updates its internal records. Counters? It increases your request count or adjusts tokens for future requests. Logs. It records what happened for monitoring purposes. Was your request allowed or rejected? How many requests have been rejected today? Why? To keep track of activity and ensure it can handle future requests efficiently. Step 5. Handling busy systems. In a busy system, many people might be knocking at the door simultaneously. The rate limiter uses safe data structures to ensure everything stays accurate, even with multiple requests at the same time. Prevents race conditions, so no 2 people get the same token or request slot. Step 6. Scaling for big crowds. What happens if millions of users flood the system? The rate limiter scales up by using distributed storage like Redis to keep track of requests across multiple servers, spreading requests across multiple rate limiters to balance the load, dividing users into partitions so the system doesn't get overwhelmed. Step 7. Monitoring and metrics. Lastly, the system keeps an eye on everything. Tracking metrics. It measures things like how many requests are processed, how many are rejected, average response times, sending alerts. If there's an unusual spike in traffic or too many rejections, the system raises a red flag to the team. Why does this matter? The rate limiter protects the system from being overloaded, ensuring it runs smoothly for everyone. At the same time, it's fair, letting users know when they're exceeding limits and when they can try again. You can visualize this whole